that's going to illustrate the underlying telemetry technology that enables remote soil moisture monitoring. And for those of you who are unfamiliar with Ranch Systems, it'll provide you with a overview of our architecture and technology. And this will take about 5 minutes, and then I'll turn it over to Mark. Okay. Oh, before I forgot to go over some of the ground rules, so before I start off here, everybody's in listen-only mode. We've got a large number of attendees. However, we want to make it as interactive as possible. So there is a question box where you could type in a question. And I'll be, when Mark's giving his presentation, I'll be reviewing the questions, and I may interrupt him and ask some of those questions during the course of his presentation. And if I don't ask your question, we're going to hold the remaining questions toward the end, and we'll answer them all then, and we'll have an open Q&A session at the end. Okay, so an overview of the enabling telemetry technology from Ranch Systems. So here we have a farm, and we have what's known as a classic web-based, cloud-based application. Typically, we have, the cornerstone of that is what we call the base station. This base station that you see in the illustration is configured as a weather station. You can see the weather sensors. So what that does is it talks to the cellular network. We also, if somebody's got Wi-Fi within range of the base station, we could also talk to the Wi-Fi network. The cellular network then has something called an APN server, where they take our data and push it out onto the internet to our server residing in the cloud. That's where our Ranch Master online application operates, and then you can access it from your computer and at your desktop, or an internet connection, or if you have a tablet, you could do that through a cellular connection or through a Wi-Fi hotspot. And of course, a smartphone. We have a mobile app. So in short, web-based, anytime, anywhere access to data. Now, typically we have something that we call a node out in the field. Our solution suite is very broad. We do with monitoring and control, and this particular node is depicting a valve control application. We typically monitor pressure in those lines as well. Sometimes we'll catch the flow at a valve location, and that communicates through the base station, which then communicates through the cellular network to our server. So the base station acts as a what we call a gateway. Now there's another node. We can theoretically we've never reached the limit, but we could connect up to 25 nodes to a single base station. And this one has a soil moisture probe attached to it. Now there's another soil moisture probe. This one is communicating wirelessly to one of our nodes. And for those of you that were with us last year, we talked about this, and we were very excited about it. And it did not materialize as promised. Well, it's still in the works, and it's proceeding slowly, but this year the wireless probes will be going into fairly widespread field trials. And this technology should be widely available next growing season. Now, I don't know whether you noticed, but we've added a camera to one of the stations. In our architecture, each node is completely configurable, expandable, and reconfigurable. So you could add functionality or you could completely change what it does. And this essentially preserves your investment in your equipment and hardware. So our typical range is 1 mile using 900 megahertz local radios that communicate to the base station. If you have a property or a part of your ranch that is outside of the range, you can see there's a distant node there monitoring some tanks. It can hop its way back to the base station. So this is what we call a multi-hop star network. Now here we've added another node. This one's monitoring pond levels, and it could actually control any kind of pump, including diesel pumps through a Murphy controller, just a regular electric pump through a relay contact. And now, recently, we've added VFD integration, where we could communicate via Modbus to VFD pumps and not only control them, but monitor all the parameters that are available as if you were at the VFD pump at the panel. It's a little LCD panel. Okay, and that communicates back to the base station. So that's a quick overview of our architecture. Key points, we do monitoring and control, weather, soil moisture monitoring, irrigation control, pump control, all types of water-related monitoring. And the system is modular and expandable. So at this point, I'm going to pass it over to Mark, and he'll start to dig in on how you use this enabling technology with soil moisture probes and apply that to determining your irrigation, how to irrigate.
Thanks, Mike.
Okay.
Am I on screen-wise?
I'm not.
You're not seeing it?
I'm not seeing it.
Okay, I got the notice that I was on. You're still not seeing it, huh? Well, this is interesting. Am I doing the wrong? You're not seeing it, Mike?
But I'm not seeing it. Let's see. There you go. No, we're seeing it now. We're good.
Well, I hope we're not really slow on bandwidth or something. Let's just try it. Let me know if there's any problems with this.
I go into full screen mode, and I think we're good to go.
Yeah. Okay. All right. Well, thanks, Mike, and thanks, Ranch Systems, for hosting this this webinar. I always feel weird at the beginning of the webinars talking to my screen like this, but I'll get used to it. A lot of you have seen my presentation before. I looked at the list, and a few of you I know already, but I think a lot of you haven't. So I'm going to kind of talk to people who haven't seen my presentation before and assume you haven't seen it. lot of what I do, I think, at least for me, because I've been doing it for a while, seems kind of simple. Maybe because, but probably because I've been doing this for a while. That said, I think that's the beauty of the system, is that it doesn't have to be super complicated. And the soil moisture probes is something I started using relatively recently. We've used them for years and years, but haven't really dove deep into using them and really used them on a regular basis until relatively recently, last several years. And it's totally opened my mind on how I work with irrigation, vineyard irrigation. And I think it applies to a lot of any crop. Obviously, the approach I take for wine grapes on the coast is going to be different than the wine grapes you grow in the Central Valley, and definitely different than any high production crop. But the soil probe information is going to be useful regardless. So let me just get into the presentation, and Mike, let me know if there's something that doesn't show up correctly. This is a slide here of a kind of a progression, a personal progression of ways of my approach to vineyard irrigation and devices I've used and combined, and sort of the evolution of my thinking. When I first started doing this, I guess professionally out of grad school, I was a big pressure bomb fan. I thought that we really just needed to measure the plant, and the plant could tell us whatever we needed to know. That's not true. The plant tells us the water status of the plant. It doesn't tell us anything about how much water is needed. It doesn't tell you how often you have to irrigate. The traditional method, I guess you call it traditional, fairly traditional. In my life, it's been traditional. It's been the ET method, or the evapotranspiration, using weather stations, just like ranch systems, but other weather stations as well, to measure or come up with reference ET values that can be translated into crop ET values, and then using that information to determine how the quantity of water that needs to be put onto a vineyard, or any crop for that matter. That's great. I used that for years and years until I started consulting in 2005, and I had some growers, especially one grower, tell me that I was irrigating too much. And of course, my initial reaction was, well, you don't know what you're talking about. Well, in retrospect, he was right and I was wrong. So I stepped away from using ET because I was irrigating around 60% of ET, crop ET, at least what my model was telling me, and apparently irrigating too much. So I stepped away from that and started just focusing on the plant. Again, not having really any other tool that I felt comfortable with. But I brought in the tool called the Perometer, and the Perometer is a tool that I've been using ever since, along with the pressure bomb. And it's something that I've used since graduate school, something I really like, but never had a convenient tool, a practical tool until recently, relatively recently, around 2006 or 7, I started using the Decagon leaf Perometer. That was great, except again, it doesn't tell me how much water the vine needs, where it's taking it up, how it's taking it up, how long it takes the irrigation to be removed from the ground after we apply the irrigation. So I was introduced to pretty much the AquaCheck soil moisture probe is what really got me going on soil moisture again. The AquaCheck, which I'll talk about extensively today, is an excellent. I think it's the best one I've seen. There may be another one out there that's better, but right now I'm using the AquaChecks extensively, and it's not only that, the people from AquaCheck showed me how to use it properly, and it's actually, like I said, fairly simple. It's just you need to put it all together. You need to look at it consistently and regularly to get the patterns that we're going to be talking about. So I've integrated the soil moisture with the pressure bomb and the Perometer, and not just in spot checking, but really that pink bubble over here says real time, and real time is really key. It's nice to have spot checks on soil moisture. It's even better to have it logged continuously. I have a lot of installations out there where we go out there every week and dump the data and bring it back and then look at it, but we can't look at it until we go out to the field. So really, it's bringing it in with ranch systems, that system specifically, because it's been, I've been partnered with them for a long time, and believe in their system, and that gives us the real-time information. So I can look at any time of the day and find out within more or less 15 minutes what the status of my soil is. And I have a dotted line going over to here, and that's sort of where we go next. And that's really automated plant water status. I've been doing the music. I've been using the pressure barometer extensively, and that requires a person going out there taking measurements. The nice thing about that is you get visual assessment of the volume at the same time, but it's also expensive. Is that just me, or am I hearing music? Okay, I've got pretty loud music. I might have to turn that off. Can you hear me talk, Mike?
I can, but the music in the background is pretty loud. It's kind of drowning you out.
I don't know where it's coming from. Let me see if it's my computer. I don't know where it's coming from. This is pretty strange. I've got pretty much everything closed. Desktop. No ideas where that's coming from, Mike? I can call in if that helps. It's not coming from my computer.
What's that?
I don't believe that's coming from my computer. Here's what I'll do. You hear that now?
It's still there.
It's still there? Okay, it's not feedback from my computer.
Well, let me start closing windows on that. It's coming from my computer. Let me
Yeah, I muted myself and it's still music.
okay, let me just look at the audio. Oh, there we go.
Okay.
I did it.
I don't know if you know what happened. Okay. Let's just keep
No
going
idea.
then. It's not going to happen again, right? All right.
Okay, thanks for
Yeah, my
bearing with
screen.
us there.
Okay.
Oh, and,
Let's move on then.
Mark, before as you resume, maybe you could address the question. You're kind of using viticulture as an example.
Yes.
Can you kind of talk to how this applies to other crops and whether the principles remain the same?
Yeah, I will. And of course, I'm always going to come back to viticulture because that's really the only crop I work with, which is a handicap to some extent. But maybe I will try to keep that in mind. I think a lot of the things that we're talking about with soil moisture specifically will apply to any crop, and I think the general method that I'm going to come to discuss will be useful for everybody. It's the plant water status, I think, that probably isn't used in some other crops. Definitely used in tree crops, and probably to some extent in field crops, but not nearly as much. So focusing on the soil moisture is really going to be where we go back to, and that's going to be universal. So I did mention the automated plant water status, and I think that's kind of where we're going. There are some systems out there already that we've considered, and we're still considering. SAPFlow, the dendrometer type of instruments, and fairly new technology called surface renewal to do some evapotranspiration measurements is another one that we are looking at. Everything we look at is going to be looked at cautiously and with the perspective of cost as well. Okay, I'm going to keep moving on. So
Well,
before the music
just
starts
as a
again?
matter of note, Jay just fessed up that it was his computer that was creating the music. That was the
Okay.
mystery.
Okay, so it wasn't Guns N' Roses, it was some other thing. Anyway, so the objectives today is really, I call it a simplified irrigation management scheme. And it's so simple, sometimes I wonder if I shouldn't tell anybody because it's so easy. It's not easy. It's easy to talk about, it's easy to do. Sometimes it's easy to incorporate because it does take a little bit of trust and a belief in your measurements. Focusing on the soil moisture dynamics, and that's kind of where it will apply to any crop. The benefits of real-time, the real-time measurement versus static or snapshot type of measurements. I'm not going to go into that a lot in this discussion, but I think it'll become apparent. A couple case studies where we did this on two different types of soil and showing the differences in how we irrigate them. And then lastly, just show some screenshots of the new graphing capabilities in the ranch systems and how that's going to help us do this in the context of ranch systems and looking at soil moisture. So I like to use a flow chart because it's kind of how I think. It's not really how I don't have this on my wall, but I believe in kind of a methodical approach to irrigation. Really, first thing is this first box up here. Is to just know your soil and your rooting depth. And the rooting depth being the most important part of the whole picture is knowing that. A lot of people think their roots go down 25 feet, and in reality, most of the roots are probably 3 feet, maybe 3.5 feet or less. Most of the time, that's what happens. You may get a deeper root. Grapevines don't really have tap roots like oak trees, but they can go deep. But primarily, the root system is much shallower than people think. But really need to know that and to do some backhoe pits and identify where your root system is. It's important to know that, not for the purpose of knowing how deep to irrigate. And it's going to vary depending on where you are. If you're in an arid climate, you may want to irrigate a little past the root zone to push the root system deeper. In a wet climate like here in the North Coast, we really don't need to do that. And actually really shouldn't do that because our root system grows as deep as it's going to go because we almost every year, including this year, start off with a full soil moisture profile. Then using the soil moisture profile sensors to determine a sort of a nominal volume and then a nominal interval between irrigations. That's going to change. We start and do what I call trial and error or iteration of volume and interval for our irrigation, and using the probes to really give us a lot of feedback on how to change that. And then also monitoring not just the plant, the soil, but also the plant water status. And this is especially important in wine grapes. As I said, maybe less so in some other crops. But we're going to use that extensively to adjust because in grapevines for wine grapes, we really want to apply I hate to use the word stress, but I'm going to. Various amounts of stress. Could be light stress, could be severe stress in some cases, but a controlled stress and to stimulate ripening of the fruit. And then this is what we do the bulk of the season is adjust interval and volume, but primarily the interval. Once I figure out how deeply that water goes, it's going to go pretty much the same depth every time, plus or minus, depending on the dryness of the soil. But I prefer to just use the interval as an adjustment, if possible. That's usually possible in smaller vineyards, smaller vineyard operations where there's not as many vineyard blocks to get around in a week or a few days. But in some cases, you're kind of tied to a schedule, and in which case you have to adjust the volume to compensate for the uptake of the vine and for the desired water stress levels you want in your vineyard. This is kind of an old slide that I've used before, but it doesn't really tell you much. But irrigation scheduling is really only two things. It's knowing how much to put on, which is the volume, and the interval, which is how often to put the irrigation on. And it's actually another one, but I could add to that, and that's just kind of when do you start irrigation. I'm thinking about this as when you do start irrigation, this is the two things you need to know about. In the North Coast especially, though, it's mostly about waiting to irrigate. That's your biggest tool that we have available to us in the North Coast. Otherwise, we're talking about volume and interval, and you have to know your soils. And this is just a real general table here. It doesn't really tell you anything other than just general concept of if you have a lighter soil or a more gravelly soil, lighter textured, which means more sandy or less clay, versus a heavier textured or heavier, more clay content soil, you're gonna not be able to hold as much water, so you're going to be going a lower volume, versus a deeper soil or a heavier textured soil where you are allowed to put more water on, in which case you don't need to put on as often. And this kind of is not as straightforward as it seems. It is for general crops, but when you're talking about wanting to stress your vines, again, only wine grapes, mostly coastal wine grapes, we're going to want to try to put some stress on them at certain times of the year. I generally revert to lower application more frequent in almost any soil. And it seems to fix issues with variations in soil across a field, but it also allows us to get really tight control over the water status of the vine. That said, though, if you're growing a crop that you're more interested in production, the deeper or heavier texture soils will allow you to put more water on and wait longer between irrigations. In any case, the soil moisture probes will give you actual numbers here, so we don't have to say very low volume and very frequent. We can say exactly how many gallons you want to put on and how often. That's what I want to talk about now. Getting a little more specific. So this isn't a very good picture, but it's just me in a soil pit talking to some people in a demonstration we gave in Sonoma County a couple, 3 years ago. And really we're just trying to show growers where roots are. In this case, this is O3916. It's pretty vigorous rootstock, but it actually, in this soil, it's a kind of a clay loam soil. We didn't see roots growing much below 30, I'd say 36 to 40 inches. And that's kind of what we're looking at here. You can't really see the roots, but that's really what we're doing. And that's something I encourage everybody to do, is rent an excavator if you don't have one. Just go out in your vineyard when it's dry enough and start poking holes and looking at your root system. And I like to show this one. This is a field, a vineyard up in Calistoga, over in Calistoga. And it's got, this is an aerial image, NDVI, Normalized Difference Vegetation Index. Don't worry, there's no test, but that will tell you more or less where the more vigorous zones and the less vigorous zones are. So the greener zones correspond to more growth and or more canopy, higher canopy density, if you will, and then the red or the orange zones are lower. And you see here that there's a couple pits fairly close together. I don't have a scale on this map, but these are only a couple hundred feet away from each other. And in which case, over here where it's in the greener zone, we measured a 41-inch root zone, and then here in the red, in the lower vigor zone, there's only 20 inches of rooting depth because they pretty much scraped the soil off here to put it down here. Pretty common, not how we prefer to develop vineyards, but this is an older vineyard, and that's how it was developed. So what do we do here? Because this particular vine row goes this direction, north, almost north-south, north, slightly northeast, and we have a situation where we're irrigating this as a unit. How do we deal with this situation, which is so common? It's extremely common. In fact, it's probably every vineyard has some of this, if not a lot of it. And my answer to that is, this is kind of my pictorial picture of that same situation, where we have on the left side it's showing shallow soil here, but that could be more gravelly here just as well. More or less just a lower water holding capacity here on the left side, versus here on the right side where we have more either deeper soil, heavier soil. For some other reason, there's just more water holding capacity in that soil, and we're trying to irrigate that with the same irrigation system. Really, what do we do? Well, one of the things that I like to do, a lot of growers are doing this now, is putting in a second irrigation hose. So you're putting in another poly line with some emitters in it. And the idea here is not to run both of these at the same time, but to know that this is going to run out of moisture earlier in the season. Again, I'm kind of a North Coast focused person. I work mostly in the North Coast. It's a lot different than in the Central Coast, where you're pretty much dry to begin with. But the concept is still interesting, I think, regardless. And some of these concepts will apply to both regions, but right now I'm thinking more on the North Coast, where we start off with fully moist profile, but knowing that this section here on the left will dry out before the section on the right, we put in an extra line here with other emitters so that we can irrigate that area earlier. So we'll start off with this zone, irrigate these vines, and these vines are going to still have moisture, so we don't need to irrigate them yet. And eventually these vines are going to catch up with these vines, and these will start slowing down their growth, and we'll be able to irrigate both of them, and then we can go back to this main drip line, which has all the emitters. This is also useful when we have interplants, replants, other just practical considerations. So what do we do when we irrigate? A lot of people will irrigate kind of in the middle or towards the, give it a good drink of water, thinking, well, we're going to be able to push our roots deep here maybe, or maybe we just want to irrigate and keep the vineyard happy. But the fact of the matter is that if you're irrigating a zone that doesn't have the water holding capacity to hold that moisture, something's going to happen. It's not going to stay there. You basically filled the sponge up, so it's going to go either below the root zone, the main root system. It can move either under subsurface if it's saturated, or more commonly on the surface. So we can get poor infiltration at the surface, and especially if there's slope to it, which there often is, it will run off. Usually down the vine rust, often into the wheel track, which causes compaction problems. So that's a situation we definitely need to avoid. So the answer for me is usually to irrigate more shallowly, and that's where I come into this more short, more frequent. Almost every situation merits that, because there's always this kind of situation in any vineyard. It just may not be this dramatic as I'm showing it here in this cartoon, but really what I find is this shorter irrigation. We irrigate toward the weaker section of the block, which means that we're not irrigating as much as these guys over here on the right want, but that doesn't matter because we're still giving them the amount of water they want. And we also have the enhanced ability of controlling water stress on the vines because of our short irrigation applications. And generally speaking, that's where I like to put our soil probes. I like to put them in the weaker zones. Not necessarily the weakest vine in the whole vineyard, but usually in the weakest 20–25% of the vineyard. And we'll use those aerial images as a tool. They're a great tool for identifying areas of weaker soil. Even better than that would be to do a full soil exploration, but not everybody has the funds right away to do that. So, but often we'll use the aerial imagery to cite where to put that soil probe.
Mark,
yeah.
I'm going to hold most of the questions toward the end just so we could get through this, but I did notice there were a lot of questions related to how many probes do you put in where. I think you answered the question of where, but
yeah.
What is can you talk to the quantity of probes?
Yeah, probably the question I get asked most. Yeah, that's a really good question, and one I get asked all the time, so it's probably good to get that out of the way now. And my feeling is you don't want to be minimalist. You don't want too much information because it'll confuse you. So picking that site is really important. I generally say that the best situation is to put one probe in a block that you're irrigating the same. And that's the ideal situation. So if you have 30 blocks, you might want to put 30 probes. But oftentimes what will happen is that you'll have 2 blocks or 3 blocks or 5 blocks that are really similar, same variety, same root stock, and maybe similar soils, and we'll stick one probe to kind of represent those 5 blocks. So obviously selling equipment, you always want to sell the most equipment you can, but that's not how I approach it. I prefer to work with the grower to kind of figure out what's most economical for them. And again, too much information can confuse you. So I find that it's really not an acreage amount. You can put 1 in 1 acre, you can put 1 in 25 acres, or even 1 in 100 acres. But if it depends on just how your control ability is. If you got one area to control, then put one probe in is probably all you really need. And that's generally what we do. And sometimes they'll want to actually look at, putting in a probe over here versus a probe over here to see what the differences are. And maybe they can split the irrigation system up and control them completely separately. But 9 times out of 10, it's we're looking at the weaker zone and identifying that as a representation for a certain amount of vineyards blocks, and then go from there. So if you have 3 or 4 different soil types, then you might want 3 or 4 different probes. But also, it really just depends on how your physical hardware is laid out, how your infrastructure is, as far as your ability to control the irrigation. Is there another one I should answer before we move on?
No, let's keep going.
Okay. Alrighty. No, I want to talk a little about monitoring, because monitoring is kind of what is all about, especially with regard to ranch systems, because ranch systems, of course, we can provide control and turn on pumps and turn on valves and what have you, but most of what people use this for, and what I'm talking about today, is monitoring soil and plant. And so I'm an engineer. My background is in engineering originally, and I'm kind of learned control systems a long time ago, and feedback is essential to a control system. So anytime you're controlling anything, whether it's a car, a diesel pump, or a vineyard, you need to have feedback, and so you need to monitor something. That's why I'm a monitoring heavy type of person. I want to know as much as I can, and so we're looking at soil, which I have down here in the yellow, which is kind of what we're focusing on today. But we also have the plant, and the plant's important too, especially in a wine grape when we're kind of trying to push it to the edge in some cases. So looking at the visual indicators, I'm not going to go a lot of viticulture today, so but it's important to look at your plant, whether it's a grapevine or tree or whatever, to see if there's something that's going on that you're not measuring, or maybe you're not measuring it at all. You just want to know. Some people don't use instrumentation. There's a lot you can see from just looking at the plant. It means you've got to be out there in the field. But there are some really good instrumentation out there. I'm going to talk mostly about the pressure chamber and the pyrometer. There's also the other ones I mentioned today, the sap flow, the dendrometers, and some of the other methods that are coming down the pike that I think are going to be exciting. But the primary ones I'm still using are these 2. And just for a review, or maybe it's not review for everybody, but these are the 2 instruments that I use primarily. The pressure chamber on the right, which is has been commonly used in vineyards for quite a while, also other crops. It's nothing new. It's been around since the 60s, I believe, and it's nothing more than compressed air in a cylinder. We put the leaf in there. We cut a leaf off and pressurize it so the sap comes up to the surface, and we can see what the tension is in the sap before we cut that leaf off. So it's telling us what the water status is, or the water potential, or the energy state of the water inside the xylem conducting vessels in the plant. It's a great tool for that purpose, and it's also, even though it looks kind of cumbersome, it's actually a pretty simple tool. There's no electronics here, just a pressure gauge and a cylinder full of compressed nitrogen. On the left, though, is a tool I've been using quite a long time. Like I said, I've been using a different type of pyrometer since, I'd say, the early 90s, but this one came around in the mid-2000s, I think 2006 or 7. I was one of the first people to try to use it. Decagon gave me a unit to try out, and I really liked it. And it's measuring something completely different than what the pressure bomb is measuring. So while this is measuring the energy state of the water inside the plant, this is measuring the stomatal conductance, or the closing or the opening of the stomatal pores. And I find this to be extremely useful for grapevines. It's used in, again, lots of crops, but to me it's telling me what the net result of all this we're doing to the vine is, and I'm able to set target values for this pyrometer and for the pressure bomb, and adjust the irrigation to get to those targets. Again, using the soil moisture as our pretty much our primary feedback. Before we irrigate, we're looking at the shoot tips. Now, again, the Central Coast is going to be different, but here we're kind of waiting for the vines to stop growing. We have plenty of moisture in the soil almost every year, this year included. Drought years, any year, we always have plenty of water. We're normally waiting for the shoot tips to stop growing, so we're looking at the shoot tips. Over here we have a shoot that's actively growing. Here, one that's slowing down considerably. From here, you see the tendrils are almost even with the shoot tip. And then here we have the leaves growing past the shoot tip. At that point, the shoot has stopped growing. And here we're just a little bit further where the shoot tip has fallen off the shoot. This is an excellent indicator of water status without a pressure bomb, without any other instrument. This will tell you very much about what's going on in the vine as long as it's growing vegetatively. Once we stop growing, then it's kind of all bets are off. We don't have this tool any longer. And most of the symptoms we're looking for, we don't want to see. We don't want to see leaves dropping off. We don't want to see a lot of leaves turning away from the sun for many varieties, because that usually signifies too much stress. So that's why we use this as an initial indicator of water stress, and then we turn to our other plant water stress measurements later on. That's enough about plants. I'm going to talk about soil moisture, and these are some of the main points that I think are important. It's kind of cumbersome here, but we need to measure at multiple levels, so I don't want just one point measurement in my soil. It just doesn't tell me that much. I want to measure it continuously. The neutron probe is a great tool, but it's kind of seen better days, in my opinion. Some will disagree, but I believe that the electronic sensors, especially when you're hooked up to a ranch systems type device, and getting that continuous information is really key, and that's kind of what I'm going to talk about in the next rest of today, this morning. We want to measure it close to where we're emitting. The dripper is dripping. I'm not going to go into that much today, but a lot of people will put these sensors too far away from the drip, and we're lots of times over-irrigating, overcompensating, because we're not sensing really the plume of moisture that's coming out of that dripper. And then we want to, as I already said, determine a volume and an interval, and rather than just talking about it, let's just go into the examples I have for you in a couple slides. These are some types of soil moisture devices. I should have substituted my more recent slide here. This MPS-1 has been replaced with an MPS-2. I don't know if anybody cares, but it's a little more reliable sensor. But the ones on the left will measure the soil matrix potential. It's sort of like what the pressure bomb's doing, but in the soil. So it's measuring how much that soil is being held within the sponge of the soil, or the matrix of the soil. It's a really good indication of how hard the plant is. It has to pull to get that water out of the soil. So it's an important measurement. But I primarily use the ones on the right, and the ones on the right will measure water content. This is the Decagon version of the water content sensor. That's one of them. I make several sensors, and they're pioneers in the field. But this is the one I prefer because it's really easy to install. It's very minimal, requires very minimal disturbance of the soil. And it's called an AquaCheck probe. As you see, this one has a cable, and the cable usually runs to a ranch systems unit. I'll talk a little bit more about this in a second, but this is my tool of choice over all these. Although if I had my druthers, I'd put in one of these, and I put in a probe, and maybe one or two of these as well, the matrix potential sensors, to get that aspect of the soil moisture as well. But what I like about this probe is based on some of the earlier probes were the Centec, the C probe types that came out of Australia. This one's actually made in South Africa. They've kind of taken that design, made it a little better, I think a lot better actually. The readings I get out of these are just more stable than the readings and cleaner than the readings I get out of the other types of probes. It's a capacitance type of probe, which I'll talk to you about in a second. And there's 6 sensors in this probe. Everything I said here, I'll show here. So let's just keep things moving. This is that probe shown kind of a cartoon and how it works. And what it does is it's a capacitance sensor. So there's like a pair of plates inside of this plastic tube at intervals down the length of the probe. So there's 6 locations where we're measuring, and any one of these probes will measure 6. And it's setting up a little electric field. It only lasts about a fraction of a second, but during that time, it's measuring the capacitance of those sensors. And the sensors are influenced by their environment because the electric field goes out into the surrounding soil. There's no physical contact between the soil moisture, and the probe, but there is an electrical field set up around each one of these sensors. And it turns out that the capacitance is influenced by something called dielectric constant or permittivity. And the permittivity of water and air happen to be at polar opposites ends of the spectrum. And the pore space in the soil is either going to be filled with water or filled with air. And so because of that, we have water and air, and we can measure the relative amounts of water and air using the capacitance. This actually becomes a very sensitive measurement of the moisture content in the soil around the probe. So convenient for us and very, very nice way to measure soil moisture. Just really briefly, and this is important, but briefly because I think pictures do more than these words. I use the multiple sensors. I want to know not just what the water content is, but where it's wet, where it's dry, where the water is being taken up by the vine, where it's not being taken up by the vine, but really how deeply is my irrigation going, and all that can be determined by these soil probes. And then I look at the summation or the average water content. So again, this is why I use the water content probes, because the water potential or the matrix potential don't allow me to do this. But I look at the sum or the average of the water content down across the whole profile to determine how long each of those intervals, or how long it takes for that moisture that I just applied through irrigation to be depleted. And that really takes 100% of the guesswork out of this irrigation practice, in my mind. That really has saved me a lot of effort, a lot of grief. I wouldn't say effort, but it saved me a lot of grief, maybe a lot of error to do it this way. And again, a picture's worth 1,000 words, so let me just get to that. If there are any questions about what I mean by this, hopefully they'll be answered in the next couple of slides. This isn't from Ranch Systems, but this is an AquaCheck probe, and I like to show this one because it's big and bold and ugly, and I can use it to point out a few key factors on how I use the probes. Then we'll get into the Ranch Systems graphical interface, which is a little cleaner. But let's look at this right now. There's a couple things you'll notice. First of all, there's a bunch of colors, and each one of these colors, I don't know if you can see it because it's kind of cut off on my screen, but each one of these represents a different level. So this one here, this blue line, is 8 inches. This red line is 16. This green, or I think it's this magenta line, is 24, and this green line is 32. And you can see that there's something going on at each one of those levels, but there's really nothing going on at these other two. This one here, the brown line, is 40 inches, and this one here is 48. So that's one thing you really notice, is that there's water being depleted. So what we're looking at here, I know I didn't say this, but soil moisture on the y-axis. This is relative water content. So I'm not using this as a calibrated. I'm not looking at volumetric water content specifically. This is I call it uncalibrated relative water content, and frankly, that's how I use 99% of my probes, is in this fashion, because I don't look at the absolute numbers, although I do have a pretty good idea what these numbers need to be, with a lot of experience. And I'm really looking at the patterns here. So you'll notice that there's nothing happening here, these two levels. Well, the fact is there's no roots there. When you see the activity uptake at these various levels and you don't see it at some levels, that usually means there's no roots. And in fact, we did a backhoe pit in this location and found about 36 inches of actual loamy soil overlying a very discrete boundary change to a bunch of gravel. Roots don't want to grow in the gravel. Actually, water doesn't want to go into the gravel. Water from irrigation doesn't like to go in the gravel if it's drip irrigated. Rainfall will, but drip irrigation doesn't like to, and rarely does. So the roots tend to congregate in the upper 3 feet, and that's what you're seeing. So you're seeing the uptake at these shallower depths, but you're not seeing any uptake here. So we don't want to try to irrigate here because we're just wasting our water. And you're not going to get roots to grow into there, frankly. So let's not just fool ourselves. A lot of people think you can get roots to grow into there. Frankly, you just can't. That's a bold statement. It really depends on the soil. This particular soil, I know you couldn't. I happen to know that just because there's just a discrete boundary between the loamy soil and the rocky layer. You see that a lot in hillsides. See that a lot in alluvial soils. That's been deposits over the years, layer cake effect. I can talk for hours on that, and I just won't do that today. I want to point out a couple other things here, though, and that's why I like to use this chart, even though it's kind of a haphazard irrigation. You see that stair-step pattern here. This is a very, I think it's unique to these probes. You can't see this on many probes, and what it is daytime we're taking up moisture at nighttime, you're not taking up moisture, so it's a diurnal type effect. So when you see that stair-step pattern, generally indicates that your root system is fairly close to where the probe is measuring. And that's what we see at all these levels. You see a little less extent here at the 32, but you still see it. So there is uptake, active uptake at 32 inches in every one of these levels down to there. And that's really important. And you also see that when we're irrigating, most of these will spike up. But you also see, I don't know if you can see on your screen, over here this green line is a little bit shifted in time, and then actually it's a little more delayed, and it doesn't spike up as much. That's, to me, I can read this very, very carefully and understand that the water stopped, the irrigation stopped above that level. This is the 32 inch, so it stopped somewhere maybe 28, 30 inches, and then it just redistributed down to 32 inches. It looks like a couple hours later, so that's, that's interesting. I know exactly how far my irrigation went in each case, and that's key. Oops. I have another example here. I'm going to skip that. This is another example. I just want to show this. Also, you see the stair steps, but you also notice it's kind of more of a sawtooth here. When you see that, it generally indicates you have a lot of moisture in the soil, because even though they're irrigating here, this was done in June of 12. I got them to stop irrigating in 2013 so much, and we didn't irrigate we didn't start irrigating until late July, early August last year, because we realized by looking at this, I can interpret this to say that there is moisture coming from other areas. So when you see this nighttime moisture increase, not just level off, but increase, that means moisture is coming from somewhere else. And generally what's happening is that this particular root system is actually really deep. It's kind of somewhat unusual that these roots go down at least 7 or 8 feet. And they're tapping into moisture deeper than what we're measuring in this 4-foot probe. And when I see that, I realize that there's moisture is coming down below where we're measuring it. It's something called a hydraulic lift. And it's using the root system to move water from one depth to another. And so we're actually extracting moisture at nighttime from deeper depths and redistributing it up in upper levels. And that's occurring, this dark line here is 48-inch depth. So when I see that, there's absolutely no reason to irrigate, because there's plenty of moisture available to the vine. This is the chart. It's not the same data, but what it is a summation of all that profile. So I'm looking at not just one level, I'm looking at all the levels at once. Now, if I could show it, I'm showing it here as a summation, which is kind of useless. It's really not a meaningful number. Or I could look at it as an average, which is a little bit more meaningful, but it's really just divided by a constant. So that I'm only looking at the patterns. I'm not looking at the calibrated values. We can put a calibrated equations on these to get volumetric water content, but I prefer to use it in this state. So what we're seeing here is an irrigation followed by another irrigation, another quick irrigation. Again, I wasn't controlling the irrigations in this block, but it does point out some interesting things. You see that when it was irrigated, initially the water content dropped pretty quickly, and then it starts to slow down, and then it starts to really slow down. And so what we're seeing here is a progression in water stress. This is actually a fairly long interval, so it's kind of a bigger drink with a long interval between irrigations. I think we're looking at about 2 weeks between irrigations, and this is actually that same soil, a fairly shallow, about 32 to 36 inch deep soil overlying rocks. So there's not a whole lot of water holding capacity, but you see initially that the vine's taking up moisture quickly, and then it slows down. What's happening over here is the vine is going into a stress, and it's closing its stomata and conserving moisture, and that's pretty interesting. But the other thing you'll notice here is that this gives us the ability to determine after an irrigation how long it took for that moisture to be returned to that same level, and that's really where the power of this device comes in. Is I can really know exactly how stressed, or not how stressed, but how long it takes to deplete the moisture back to the same level. And in this case, we're kind of looking at re-irrigating at kind of a stress level. But if we put that re-irrigation point, which is kind of this red line, I'm just kind of hypothetical here. Right now I'm showing this red line at the point where this readily available moisture goes away and we start getting into the more stressed level, we can put that line anywhere as a reference line to where we want to irrigate again. That's what I'm going to be talking about now. And that's how we kind of control not only the stress, but we use it as a reference line to determine how long it takes to deplete our irrigations, which gives us a really, really tight number to determine our irrigation intervals. I'm going to ignore this for now. Here we have that, I put a reference line down here, but in most cases I've kind of changed and we're moving to a shorter, more frequent type of irrigations. We don't necessarily want the vine to go into happy and stressed mode. We want to keep it kind of moderately stressed, so we're using a little bit different approach now. But the idea is you can put these lines in. This will become your reference point for that vineyard going forward. It may take some tweaking, after a little bit of trial and error. And maybe you got too stressed. Maybe you want to kick that a little higher. But it gives you that point. I call it calibrating it for the site. And this is really where the power of this tool comes in, is where you calibrate it for each site and put your reference line. You can call it a refill point. A lot of people call it a refill point. So in essence, your trigger for irrigation. Okay. Let me skip through a couple of these. This is a grower. This is from a Ranch Systems installation we did several years ago. I put it in a grower's vineyard. It's in the southern part of Napa, and it's only third leaf, so you didn't want the vineyard to get stressed, but you wanted to know what's happening. He did several irrigations until he got it right, until he felt he had it right. So that's what this was here, was really trying to figure out how long does it take, how many hours do I need, or how many gallons do I need to put on until I get pretty much to the bottom of the root zone and not really any more. And so after a couple tries, he got that figured out. I don't know, what, about four gallons, or maybe it was 6 hours. I can't remember exactly what his application was. And then he got into trying to get this repeating pattern. So in Ranch Systems, we can put in a band, and I like to put the band kind of where those reference lines were in that previous slide, where we have, this is our refill point, this is kind of what we call a full point. We try to keep it within that band. Now that's not a deficit irrigation, that's not what people call deficit irrigation. I'm irrigating it and keeping it more or less the same water stress level or water status level here. If I want to, I can stretch this out and make it go into a deficit and go lower water content in the soil, or I can push them closer together and make it go up. That's where we have the control. And the closer we put these irrigations together, the more control we have. So that means a lower volume, more frequent type of approach. In this case, though, he was growing a vine mainly to develop a root system. So we didn't want it. We wanted to irrigate fairly deeply. We went down around 40 inches or close to 32 to 40 inches, and maintain that fairly moist, and then irrigated. As you see, we didn't let this flatten out at all. It was irrigated so that it pretty much stayed at fairly high moisture content. Because again, this is being, trying to develop a good vineyard here, not really for the purpose of manipulating wine quality at this point. But I've done this exercise several times using this method. So this is that same data, and we have an irrigation here. He irrigated, it looks like 6 hours here, 6 hours here, and again 6 hours here. At 6 gallons per vine in each irrigation. And I took this period of time from here, this first irrigation, the second irrigation, right before that third irrigation, and took the ET values for that. I determined it was the crop ET, using this crop coefficient, was about 66 gallons per vine. We put on 12 gallons per vine. The vines were happy. The vines never got really stressed, and we only used 18% of full ET. I've done this several times in many of these projects. I usually don't use ET anymore, but once in a while I like to go check. And it almost always invariably comes out between 18 and 22% of full ET. And so my opinion is that the ET method is kind of missing something. I think it's missing the stomatal closure that we're getting in grapevines that occur late in the season. Now, it may not be true for other crops. It may not be true for grapevines grown in the Central Valley for 20 tons an acre or 15. That may not be the case there, but it certainly is in the coast. And most of the vineyards I've worked with, I've found that we're using very little water relative to what we would think is a deficit irrigation, like 60% ET. We're using more or less a third of the amount.
So
this is
we're on the hour, so maybe what we should do is just kind of zoom through the remaining, kind of go through the remaining slides quickly, and then we'll go to Q&A.
Got it. Okay, let me kind of breeze through here. Then I won't talk much about it. Essentially, what we did is we did a project at CME up here in Alexander Valley. Two very different soils. Both were Cabernet vineyards, and both were. We had two blocks, and we irrigated them side by side. I'm not going to talk about the treatments. We did make wines out of this, and it's kind of a cool project. But what I really wanted to show is these two vineyards have very different soils. Red Fan has a fairly heavy, I would say, clay loam soil, and the Landslide has a loam soil, but a very gravelly, extreme gravelly soil. Very low water holding capacity. So this is the Landslide block, lots of gravel in the profile. Root system, it does go down a couple feet, but not too deep, not really that deep. It doesn't have a lot of water holding capacity in the soil. And this is how we irrigate it. So this is kind of a twice-a-week irrigation, sometimes even 3. But you see we're irrigating fairly often. Each one of these is 2 days between these bars, the vertical bars. So we irrigate it roughly every 3 days, more or less, trying to keep it within this band. And we could not get the water very deep, so we try to get the water deep, but just doesn't go deeply in the soil. So we're fine irrigating shallowly, but because we had to irrigate shallowly, we had to irrigate often. And it actually worked out really well, and the vines were just really happy. They didn't get stressed, they didn't drop any leaves, and they actually made extremely good wines. This is actually a really high quality wine site in Alexander Valley. This is the other site, the heavier soil. Not much gravel content. My photos aren't that great, but this soil can be irrigated quite a bit differently if we wanted it to. And it turns out a lot of people don't know this, and I'm not going to go into a lot of this. Oh, I don't, because we're out of time. But it's amazing that this soil, we could easily get water down to the bottom of the profile. And you see here that this one irrigation went down. Our lowest level here is this green line here. And it did go up, so we got down to 4 feet with about 3 or 4 gallons of water. So I think it was about 3 gallons of water. So it's interesting the differences in the soil types, and it's really quite contrary to what a lot of people think, that the rockier soils will go deep. That doesn't really work. That's not really the case in drip irrigation. I'm not going to go into that right now because we're out of time. But we irrigated them very differently, and we use these as a tool. I want to just go on a few screenshots I did recently. I did these last night, just to show a few things, and then we'll stop. This is something that Ranch Systems has. I don't really use this personally, but I think it's kind of interesting to look at sometimes. I like to look at squiggles in charts, but this is a pictorial presentation of soil moisture over time. This is up to yesterday, and this is the red is showing low water content. The blue is showing high water content, and of course the green's in between. You'll see that we had this pretty long, very long dry period before we got any rain in February. You see that the soil was quite dry, and then we had that big rain early February. It pretty much finally filled up the moisture profile, so we have this nice blue up and down the profile. And as time progressed, this is that Landslide. This is that gravelly soil. It doesn't hold water very well. You see it progressively lost water. Then we got another rainfall, filled back up to close to the surface, depleted again, and we just had a couple days of rain where it filled up again. I think this is a kind of cool way to look at it. I normally don't use this as my irrigation tool, but I like the fact that you can do this in Ranch Systems, and I think it's pretty interesting to look at it this way. Also, I wanted to show you this, and it's probably not super clear to a lot of you, but you can look at this graphically. You can look at it with this profile pictorial. This is just the beginning of last year, springtime, and we started off with sort of a full profile up and down. So this is depth. I didn't mention that, but this is depth, so shallow, deep. We're looking at kind of a slice over time of that profile. And you'll see that the profile starts drying out in the upper levels first, and then it starts depleting moisture down deep. We have moisture down here at the deepest level quite a long time. We didn't start irrigating this block until September, and you'll see that by the time we started irrigating, we had moisture still down deep. And that's really where this probe's come in handy, because you can see a lot of times you'll see bone dry soil, which it was up here. But if you get down there where there's actually roots taking up moisture, you can see that it's actively taking up moisture down deep, and it prevents you from pulling the trigger on irrigation. And to me, that's the biggest water savings that you can achieve in any agricultural situation, but especially wine grapes, is just to wait to irrigate. And that's kind of what we're saying here is not only are we waiting to irrigate, but we're letting this root system remain active. Once we start irrigating up here, that uptake will stop down here. We no longer will take up moisture down here, and the roots become less active or even inactive. I'll skip that one. I'll skip this one. I do want to just talk a little bit about the new graphing capabilities of the software. This is the kind of what I've showed you before. This is that same block, or one of those blocks. This is the red fan, the deeper, the heavier soil. And you see what the normal irrigations we irrigate. This is the volume, the average water content here where we put the bars, and this is the levels down here. We've got some other new tools now where we can show that. Oh, well, here's something else. We can annotate the graph. Say, for instance, putting how much do we irrigate each time. We can put anything. We can put water status comments on here. We can put, this is vines were too stressed here, or yellow leaves, or shriveling berries. We can put notes on our charts now, which is pretty cool. And it's very easy, and you can remove them or not show them if you don't want to. We also have the capability of splitting out. They call it a stacked chart, so we can look at each level independently. So this is our average, and these are each individual level, which allows us to look at kind of a detailed picture. They're not on top of each other anymore, so we can look at them at each level independently, and that's pretty cool. I think that's a nice move on Wrench Systems' part to put that feature into the graphing. That's pretty much all I had to say. I'll leave the slide up so you can read it, but I think it's a good time to turn over to questions.
Okay, great. Thank you very much, Mark. Very edifying as always. We're going to stay online here and just go through the questions in order. We had a lot of people, and there's a lot of questions, so it may take us a while. If you don't have time to wait to get your question answered, we are going to be, we've recorded this webinar, and it'll be posted on our website in a week or so. You could review it and move through it, kind of scroll through it to get to the parts that you're interested or answers to your questions. Okay, so with that, let me just say one more thing before we launch into this. There you have Mark's contact information, and if you have interest in Wrench Systems, you're out of the North Coast area. You could contact us by sending us an email at sales@wrenchsystems.com. Again, that's sales@wrenchsystems.com. Okay, questions? Got a lot of questions.
Hopefully I only have one answer.
Okay. Okay, let's start here. Can you use your system manually, meaning as one sees that it is fine to water, you can do it manually?
Oh, can the irrigation be controlled manually? Is that the question, I believe?
I think that's the question, yes.
Yeah, of course, absolutely. That's what I'd say 90 or more % of the people do. The automated valves are great. A lot of people do want that, but it's absolutely not necessary to do it that way. The measurement is the key, in my opinion, and that's what most people do. Is we'll hand operate the valves, of course, and do everything by hand, but taking the measurements automatically like that. So it's not really an automated control system, but it is an automated measurement system.
Okay, can you scale this to be used in greenhouses?
Yeah, sure. There are those AquaCheck probes come in different lengths, and I use the 32, 40, and 48, and the 60-inch probes for vineyards, and you would want that for trees as well. But they do make short probes. They're, I think, down to, geez, I don't know what the shortest probe is. I know they make a 24, but I believe they make shorter probes than that, and they won't have as many sensors, and then they only have 3 or 4 sensors. I don't use them, so I'm not too familiar with those, but they do work that way. Or you can use the those Decagon type, and actually Decagon makes specific sensors for greenhouses, they call it for soilless media, that probably would work very well, and you can use those as your water content measurement as well. This is definitely appropriate for greenhouses.
Okay. Can you get a rooting depth map on 5 acres?
Can you? Yes. You can do it on 1 acre. But what we normally would do is, and I work with another company that does soil maps, and for 5 acres it's probably not cost effective, but there are things you can do using either electrical conductivity as your basis, or using an NDVI aerial image, which really can be obtained fairly inexpensively, and then using that as your guideline to go in there and dig your soil pits. So you can dig soil pits based on, go in your weak zone, go in your vigorous zone, go in your intermediate zone, and kind of figure out what the main differences are. So you can do it at any scale.
Okay, I think a question related to placement of the probe. This would be good to kind of, I know you covered this, but it'd be good to go over it again. How many inches do you set the probe from the vine?
Okay, good question. And I kind of brushed over it, and I have a lot more slides I could have shown, but I knew I was going to run out of time. It's really what's most important is how far away from the emitter you put it. And I found that it depends on the soil, but a lot of soils will not get lateral movement very far away from that emitter. Even 8 or 9 inches, you start getting into the fringe. So I like to put my soil probes about 4 inches away from the emitter, and that's because I don't want the emitter to drop right on the probe, basically. But if it drops right next to it, I'm okay with that, as long as the probe's installed well, and you don't get channeling down that probe, which we prevent by doing a slurry backfill and preventing that. That's key. It's really important to put it really close to the emitter. As far as away from the vine, generally I like to, if I'm going to put a direction away from the emitter, I usually go towards the trunk of the vine, but I don't find that it really matters that much. I pretty much get the same information on either side. Clearly, if you just planted your vineyard, you're going to have or anything, your orchard, I guess, for that matter, you're not going to have that many roots that far away from the trunk. But as the vineyard is established, it's going to develop a root system. In the North Coast, in a moist climate, we'll have roots everywhere. In a drier climate where you're just relying on drip irrigation, you're going to have most of your roots under the emitters. And so that's why it's important to put it near the emitters anyway, because that's where the roots are going to be proliferating, and that's where you want to measure.
What percentage of your vines need to show water stress before you irrigate?
That's a good question. I was asked that just the other day. I am more leaning towards stressing most of the vines. Now, in a perfect world, and a lot of times a lot of the growers I work with now have a secondary irrigation system, not system, but a second polytube. So they'll irrigate the weak sections first. So once they start drying out, we'll irrigate then. We don't have to make that call as dramatically. So we'll irrigate the weak when they stop growing. We'll irrigate them, or if they slow down too soon, we'll irrigate them earlier. But if you only have one irrigation system, then yeah, I don't want the other ones to defoliate. But generally, what's going to happen is that weak zone will precede the same effect maybe 2 or 3 weeks later in the other part of the vineyard. So I prefer to wait to 80 or 90% of the vines have stopped growing or have reached the target. Again, this is the North Coast. It's very different in the Central Coast. and probably Central Valley as well. But I'm generally waiting for, I'd say, 80% or more of the vines to stop growing before we irrigate them. Because once, they're not going to go, they're not going to, well, again, it's a rootstock thing. 10114, 5C, we've got to be very careful about. 110R, 1103, the drought-tolerant rootstocks, we can push them harder, so I'm not as worried about them. So there's lots of factors that come into consideration here. To give you a general answer, is can be misleading, but I generally want all the vines to stop growing. Maybe not all of them, but most of them to stop growing, because if you start irrigating vines that are growing, they're going to continue to grow, and that's a real problem. Once they stop growing, you're not going to start them up again. So that's kind of what I'm hoping for. I'm just kind of putting the brakes on and then starting to feed them, moderate amounts of water just to keep them satisfied.
So, there's another question related to probe placement. Is the distance from probe to dripper different on a hillside?
Well, there's other factors depending on the severity of the hillside. Yeah, usually on the hillside, I'll put it on the downslope of the probe, because you may get a little bit of runoff, even if it's just a real localized runoff, just a few inches or even. So I'll tend to want to go downhill of the probe. I'm sorry, downhill of the emitter instead of uphill. So that's really the only thing I worry about. I still generally go 4 inches away regardless.
Okay, I could answer a few of these questions quickly. If our vineyard doesn't have cell service, what are our options? Well, I think the principal option there is if you can get a Wi-Fi connection within range of the base station, then you could communicate with Wi-Fi. We're working on satellite, but we won't have that available for a while. And it's also much more expensive to go through satellite. Let's see. What is the moisture monitor probe that you recommend? I think you covered that, Mark, but if you want to touch on it again.
Yeah, the one I really like is AquaCheck. That's sold through Ranch Systems. I also deal with it too, but I deal with Ranch Systems as well. I like that probe. Of course, I sell it, so I'm a little bit biased, but I chose that one because it's the one that gives me that clean signal. I've used other probes, and they seem to be more biased, more influenced by temperature, diurnal temperatures. I get a lot of noise out of them. So I really like this probe. The other ones I like the Decagons in a lighter textured soils. They work fine. Heavier textured soils, I've had some problems with them, but AquaChecks are definitely the ones I prefer.
Okay, these are related to interpreting the charts. I'll just ask this one. It seems really complicated learning to read the charts produced by the probes. What's the learning curve?
Yeah, it seems complicated, and I think that's probably the initial reaction of a lot of people, but that's kind of where I step in and try to help anybody that gets these, well, at least for me. I tended to train them on how to read them and help them kind of calibrate them for their soil. And of course, I do a lot more consulting with a lot of clients who work just very heavily with them, and it may take them a while to learn them, but usually what I found is that it may look complicated at first, but once you start using them, it's actually fairly simple. Like I said, I'm not really looking at the actual numbers on the y-axis that much. I'm looking at the patterns, and you start looking at identifying the patterns. It's not that mysterious. It's just your initial reaction might be complicated, but with me looking over your shoulder, it gets, actually, I found most growers have given me, everybody, I haven't had anybody upset with these probes yet, or the readings that they're getting from. They're all saying, yeah, why didn't I know that before? It just seemed so obvious. So it's definitely a pretty quick learning curve. I think, within a couple of weeks you got the gist of it, and then within, after a season you're kind of a master at using these things.
Okay, this was related to, I think, back to the charts. How are the horizontal blue and red lines set? What do they mean? I think that's kind of, I think, related to setting the bands, I think.
Yeah, we set those. Of course, we're measuring not just the soil, we're measuring the plant, identifying when they slow down, when they stop growing, looking for certain levels of leaf water potential, stomatal conductance. But if you're looking for only one thing, just looking for the shoot tips to stop growing, that kind of becomes our point where we want to keep it at. So we'll put a point, usually based on all the factors, the refill point, that's that red line that we showed you, or the bottom of that band. That's really the most important thing right there, is that bottom of that band, because that's going to be your reference line. That's your status line, your status quo line, if you will. So if you're at some level of water stress, whether it's not stressed at all, or if it's severely stressed, or something in between, that's going to be your target to keep it at. And if you want the vine to get less stress, you raise that level. And if you don't, you want it to get more stressed, you lower the level. And that's again an iterative process you do, usually and oftentimes in conjunction with somebody like me who kind of guides you along the process, but not always. A lot of people want to do it themselves, and that's just fine. The upper level is I call the full point. That's really kind of there it's more of a visual, because you're probably not going to irrigate over that level, but you may have a tendency or want to try to push it higher than that, but we don't. We want to try to keep it within that band, and that's again a trial and error. So it's figuring how much volume it takes to get to the bottom of the profile. I'm sorry, not the bottom. At the bottom of where you want it to go. When I'm talking about irrigation depth, that becomes how much kind of your volume, and that's going to almost determine that height of that spike in that blue line. I showed blue line there, but it can be any color. But the average line or the total, and that's going to be we kind of set that upper line. Really what happens is it goes up and it drops down really quickly, and that's kind of a drainage. And then once it settles out there, that's kind of where we draw the line. And we try to keep it that upper level to reflect the full capacity. It's not really technically a full, because we're only irrigating a small part of the soil. It's really that bottom part of that, either the band or that red line that we drew in those other charts. But the bottom of that band is really the key, and that's our refill point. When it gets to that level, that's when we want to irrigate, and that's to me, that's the whole trigger right there. And that's the crux of it. So picking that point is very important. So it's not trivial. It does take a little effort.
Are the monitors and base stations solar powered? What versions of 802.11 does your Wi-Fi solution support? What is the max distance from the Wi-Fi antenna? So let me answer those quickly. All the ranch systems nodes and base stations are solar powered. If there's power on available, they could also be powered through a power adapter. I don't know. I don't have the technical knowledge to know about the 802.11, but we're compatible with any kind of Wi-Fi. The distance, it depends on the strength of the Wi-Fi router, but typically I think the max is about 100 feet. Depending on the Wi-Fi router and the kind of what's if there's the interference between that and the base station. You said, next question, you said be very careful about rootstock 10114. Why?
Oh, well, again, a little bit of cultural here, but 10114, and there's a few others like it, they're just not drought tolerant, and what will happen is those rootstocks have a fairly shallow root system usually, not always, but most of the time, fairly shallow root system, and 10114 specifically seems to be one of the more sensitive rootstocks. So if it does get overly stressed, it tends to stay that way. It kind of keeps the vine, in desperation. So that particular rootstock, you just don't have a lot of forgiveness. whereas in some of the other rootstocks like 110R, 1103, some of those type of rootstocks will have a lot more, I call it resiliency, so you can push them harder, and they'll basically, once you start irrigating, they'll spring back to life. But the 10114 and 5C tends to be the same way. SO4 to a little lesser extent, but kind of the same idea. We'll have a hard time bouncing back, and I think that's has to do with the architecture of the root system is different. It's a lot closer to the surface. It may have something hormonally that are different between that rootstock and some of the others that just basically don't allow the vine to recover as easily. Nothing's absolute. Some situations will work just fine, but generally that's a rootstock in particular I have problems with, going too far, and you got to be careful with that rootstock.
Okay, and I think the final question, I think we covered it, but it's worth going over again, is that what are the depths should the probes be placed at?
Well, I normally use the probes that are fixed depth, so those are all built in. They're built into the probe, so you can't adjust them. So you get what you get, and there are probes that there are probes that you can bury, called subsurface probes, but generally we're leaving them up at the top of the surface. Hang on. So generally we leave them at the top of the surface, so we're basically left with, like the 48-inch probe will have the sensors at every 8 inches down to 48 inches, and that usually is my favorite. I usually most of the time, if I can, put a 48-inch probe and get those levels. And if you're using discrete sensors, then you want that last sensor, the bottom sensor, to be sort of towards the bottom of the root system, if not just slightly below the root system, and then you want one probably around a foot to 18 inches, and then probably one between. So if you're using discrete sensors, you want at least 3, if not more. One at the bottom, one towards the top, and then one in the middle, obviously. But generally I like to make them more or less evenly spaced. I don't really try to pick horizons, soil horizons. I try to pick depths, but there may be a reason to put them not so much equally spaced. If your soil has a layer cake effect, you maybe want to capture one in each one of the layers, or some of the layers, so that especially if you think that water won't move from one layer to another. So it's it's not completely straightforward, but when I use the Aquachex, there's really no guesswork. You just kind of stick it in the ground, and it measures where it measures.
Okay, well, very good. Well, thank you everybody for joining us. Those are still listening. Mark, thank you very much. Another
welcome.
Great presentation.
Thanks for your attention.
And again, this will be recorded and posted on our website. Everybody have a good day.
Thank you.
Bye.